Hi everyone, welcome to today's lesson. Today's lesson 4, it's about rational functions. We're going to start off by reminding you what a rational function is again. So a rational function is in the form f divided by g. So by the way, rational is just a division statement or a fraction statement. It's always something divided by something else. In this case here, we're going to be using two different functions or sometimes two of the same functions. It's something f of x over g of x, where g of x can never equal 0. Because we have a rational function, we have to add on two new keywords. The first keyword here is called vertical asymptote. It is a vertical line that the curve will approach, but it will never cross or touch this actual line. So if you had a grid, and here's like your y-axis and your x-axis, a vertical asymptote will be a line, and it should be a dotted line usually, dotted line going like that, and your graph will never touch this line or cross this line. That's what a vertical asymptote is. Horizontal asymptote is the exact same idea, but of course horizontal just meaning left to right. And again, it's a line that your graph will never touch or never cross. It'll get close to, and it sometimes looks like it crosses on your calculator, but it actually never actually truly touches. So to find vertical asymptotes, quite easy. Vertical asymptotes are NPVs or non-permissible values. They're always in your denominator. It's any value that's going to make your denominator 0. So for vertical asymptote, always think what's in your bottom, what's in your denominator. For horizontal asymptote, we have three different cases that we're going to talk through. And the first one here is if your largest power, aka your largest degree of x, is the same in your numerator and denominator, then your horizontal asymptote is the coefficient of that largest power, so largest degree. So what that means here in this example, here in the first example, is I have a numerator of 3x. I don't worry about that plus 6 at all because it's not my variable. I only look at my degree in my variables here. So I got 3x versus 2x. Both of these have the same degree. Their degrees are 1 each. And so because they are 1 and 1, all I do is look at that coefficient, 3 and 2, and that's now going to be my horizontal asymptote. So I can say something like HA, for short for horizontal asymptote, is going to be at y equals 3 over 2. And so what does that look like if you're graphing really quickly? So that would look like if you had a graph here at 1.5, which is, so here it'd be 1, 2. So around 1.5, you would have, and this is horizontal, so I'm going to draw my other lines on there. 1, 2. So horizontal meaning left to right, 1.5 here. We would have a dotted line going this way here. And I apologize that my graph is slightly crooked, but I believe you get the idea. On this next one here, our largest degree is x squared, by the way, and 4x squared. So that's my largest degree. Don't look at any other variables. You don't need it. You just need to look at the largest one. So again, here, because I have x squared up top in my numerator, x squared here on the bottom, these are my largest. I take their coefficients. Well, the only thing I need to default in right now is a coefficient of 1 in front of that x squared there. So here, I have a horizontal asymptote of y equals 1/4, 1 over 4. On this last one here, this one here, I'm going to put a star on it. Slightly tricky because it's in a different format compared to these first two. This last one here, again, I'm looking at my numerator and denominator, looking at the variables there. Yes, there's a 3x up top, 2x on the bottom. That's what I'm going to compare. So my horizontal asymptote, again, following convention, should just be the coefficients. So it's going to be y equals 3 over 2. But the kicker on this is this, all of this here is my function, and then I have this plus 2, which is a vertical translation. So if I have a vertical translation, it's going to affect my y values. So I need to, on top of finding my horizontal asymptote, translate it up 2 units. So I'm going to go plus 2. So in this case here, my horizontal asymptote now is equal to, well, 3 halves plus 4 halves, which is 7 halves. So basically, you took your original horizontal asymptote and you shifted it, or you translated it up 2 units. Everything is going to be up 2 units. So that's the first one. So again, the first one is what I call same. You're looking for the same variable with the same degree, numerator and denominator. All you're going to do is look at the coefficients. So this is the case of what I call same, same. In the next case here, this is when you have a larger degree in your numerator, a smaller degree in your denominator. In this case here, we have no horizontal asymptote if you have something larger up top and something smaller on the bottom in terms of degree. So no horizontal asymptote here. And when I write down my answer, I really do write down no horizontal asymptote, no HA or something along that line there. On this end, by the way, this is what I would call big small. So you have the case of big over small. You should have no horizontal asymptote. On this last example here, the case here is we have a smaller degree in the numerator, a larger degree in the denominator. So if you have small over big, sorry, I'll switch colors here. If you have small over big, so small over big, you're always going to end up with a horizontal asymptote exactly on y equals 0. Okay, so this one here, your horizontal asymptote is always going to be at y equals 0. Um, and again, that's because your degree in your denominator is going to be bigger than your degree in your numerator. Another example of this last scenario that you may or may not run into is the following example, and I'm just going to jot it down for you. F of x equals, and let's say we don't have a variable in our numerator. Let's just say it's 4 over x minus 3, something like that there. And again, this picture, or sorry, this example here that I built falls under this same category here where you have small over big. Well, small would mean that in your numerator you needed an x with a variable there and a degree. Well, here if you don't see it, it's always going to be x exponent 0, by the way, because x exponent 0 kind of goes away. Here in your denominator, that's a 1 there. So you have 0 over 1 technically. So here, even in this case here, if I had to list off my horizontal asymptote, it'd still be at y equals 0. And again, for this fact here, that even if there is no x here, you can default in an x exponent 0, which is just 1. So now we're going to switch over and work through some examples. So it says given f of x equals x over x plus 5, determine the equations of the asymptote and the domain and range in this example. And we do have a grid off to the far right here that we can sketch our graph as well. And I'm just going to do that on my graphing calculator as well, just an FYI, but just to double check. So vertical asymptote first. So this one here, you're always looking at denominator. So my note here to you is look at denominator. And it's what is x so that you cannot be 0 there. So right now I have x plus 5, and let's say all of that cannot equal 0 in the denominator, so moving that 5 to the other side. So x now cannot equal negative 5. So there you go, I have a vertical asymptote here where we can say x cannot equal 5, so therefore you have a vertical asymptote at x equals negative 5. So mathematically we know x cannot equal 5. That's what's going to fit here. The way that we write it out though is vertical asymptote at x equals negative 5. So right at x equals negative 5 on my grid here, I'm going to draw a vertical line straight through, denoting that that's my vertical asymptote. So I have 1, 2, 3, 4, 5. And there you have it. That's going to be my vertical asymptote. Switching over to our horizontal asymptote. So again, I got to go through the 3 scenarios that I just learned about above. So what do you have here in terms of degrees? Well, do you have same for degrees, a big one and a small one, or a small one and a big one? Well, in this case here, you have same. You have x and x. They're both coefficient of 1 and 1. So for my horizontal asymptote, I can say something like y is equal to 1 over 1. Well, 1 over 1 is just equal to 1, so at y, so then I can say therefore we have a horizontal asymptote at y equals 1. And again, I'm going to find where y equals 1 is on my grid here, which is right here, and draw a dotted line right through, denoting that that's a horizontal asymptote. And again, 99% of our time when we're drawing these horizontal or vertical asymptote, we're going to use dotted lines. On your graphing calculator, depending on the version that you have, You may or may not see these dotted lines, and that's just all dependent on your graphing calculator. So here I have my two vertical asymptotes drawn in already. I just need to pull off some values off my graphing calculator to draw the rest of my graph here. So I'm going to go straight to my graphing calculator, type in this equation. So I have x divided by, and be very careful here, I'm going to throw the denominator into brackets here, x plus 5, close bracket, hit graph, and that's what our graph is going to look like. Go second, trace to bring up some values, and you're going to try your best to pick a few values that's going to work for you. And of course we have an error here because that's going to be our vertical asymptote. So pick a few values that's going to work for you and graph. I'm going to quickly pause and graph as well. And here we go. I have my graph done for you here. Just a quick review. Again, I tried to graph as many coordinates as I could that were as whole numbers, and then I tried my best with some of the fractional numbers, so like 0.25 and stuff like that. So I tried my best, and this is what we ended up with. So same thing for this graph here, or for this example 2 here. So we want to find out what our vertical asymptote, horizontal asymptote, and then graph the same. So again, starting in my denominator first. So x minus 1 cannot equal 0. So therefore x cannot equal negative 1 there. Oh, sorry, x cannot equal 1. Sorry. X cannot equal 1 there, not negative 1. So I have a vertical asymptote at x equals 1. So again, vertical asymptote at x equals 1 going up and down. I'm going to draw a dotted line at 1. Let's talk about our horizontal asymptote. Well, here you have this scenario where you have a larger degree in your denominator, a smaller degree in your numerator, because I don't even see it, so I'm going to default it in as degree 0. So if you have larger in your denominator, smaller in your numerator, therefore your horizontal asymptote out of those three cases has to be at y equals 0. And from here, I'm going to draw in my lines as best as I can. And again, if you want, I would graph this on your graphing calculator and then pull off values to draw your graph here. And here we go. I just redrew out our graph here. And again, found some of these coordinates right off of my graphing calculator. If it helps speed things up for you, that's what I would do, is go second graph. Once you have this entered in on your graphing calculator, pull off values, and then you can create the same grid here as well. Just an FYI, another way to do this is once you figure out your asymptotes, if I have 3 in my numerator there, that means I have a distance of 3 away from this origin is going to be my first dot. So 1 to the right and 3 up, and 1 up, 3 to the right, and there you go. Those are my coordinates, and that's what I did on both, and that's just a trick real quick to figure out some of your coordinates. Here, what we're going to do is we're going to transform or play around with our rational function. So here's our base rational function, 1 over x, and we're going to transform it using this equation here. All your transformations are still the same. A is a vertical stretch, H is a horizontal translation, and K is a vertical translation. Sorry. Notice that there is no horizontal stretch. There's no B value at all here. So just make that a mental note. There's a little other 2 bullet points down here that I do want to address. These 2 bullet points say that the graph has a vertical asymptote at, so vertical meaning up and down, at x equals h, whatever my h value here is. And then my graph has a horizontal asymptote at y equals k. And so again, our k value, even though that's vertical translation, it's going to shift our horizontal line either up or down, depending on it. So going to our example here, so we have graph 1 over x and then graph our g of x on the same grid. So we have our grid right here that we're going to try to graph both, state the restrictions on the variables, and then write the equation for all asymptotes. So I'm going to start off by graphing. And so here's how I graph. So our original graph here, this is 1 over x. So I'm going to have my graph kind of curve away from my y and x axis. So the original one, let's do the original in blue. So my original graph is just going to turn right through that first coordinate that I put there, which is at 1, 1, turns away, and there you go. That's my original. And on the other side, going through that coordinate, turning down, and running this all the way straight down. And so there's my original. On my new one, I got to figure out my horizontal and vertical asymptotes. I'm going to fill in all that first, and then I'm going to draw my graph here. So on my new one, let's take a look at our denominator. So x minus 3 in our denominator. So that means x cannot equal positive 3. So therefore, we have a vertical asymptote at x equals 3. So I'm going to draw a vertical, sorry, that's at x equals 3. So I'm going to draw a vertical dotted line at x equals 3. So I got 1, 2, 3. There we go. That's going to be my vertical asymptote. My horizontal asymptote, well, again, this is going to be small over big. So usually my horizontal asymptote should have been at y equals 0, but we have this plus 4 that I need to add on. So it's going to be originally y equals 0, and then we're adding 4 because we're shifting everything up 4, a vertical translation of up 4. So that moves our horizontal asymptote up 4. So now we have a horizontal asymptote at positive 4. So again, I'm going to draw a line right through at positive 4. So here is my grid, more or less, my two asymptote lines that I've set up. And then I'm just going to draw a few coordinates, and then I should have my grid. So again, my quick trick, once I have my vertical asymptote and horizontal from my origin of that, I'm going to go out to and out to again, and the same thing down here. And I should be using a different color, but that basically gets the job done. Let's do this one in red and connect our dots. So we would have a graph that kind of looks like this, going through both dots, turning, and trying not to cross through those lines there. Then the same thing here, going through that first dot, turning through the second dot, going straight down. Sorry, my line's a bit curvy, but it's just going to run straight down right next to that asymptote there. So I have my two graphs superimposed on each other. So state some of the restrictions. So on our original f of x function, we have x cannot equal 0 because that's my denominator there that I'm dealing with. On my g of x, again, we have x cannot equal positive 3 there, because we would end up with a 0 in our denominators there. The next part here is write down all asymptotes. So again, let's start with our original, and then we'll go with our new. So our original, our vertical asymptote was at x equals 0, and our horizontal asymptote is at y equals 0. That was all from the original. And on the new one, we had a vertical asymptote at x equals 3, and a horizontal asymptote. This one was our tricky one. It's normally at 0, but then we shifted it up 4, so it's going to be at y equals 4. Describing all transformations that occurred to get from the basic function to obtain g of x here. So things that I see a vertical stretch. That's going to be by a factor of 2, because that's what this 2 up top is. I see a horizontal translation 3 units to the right. And of course, I see a vertical translation that's 4 units up. On this next example here, example 4, what I'm asking you to do is write down what the equation might be. So based off of these graphs here, write down the equation. And again, we want the equation in this format here, a over x minus h plus k. So again, just a real quick reminder what h and k are. I flipped back 2 slides because I want to remind you of what h and k are, and it is again right here. I'm going to put a star next to this, and this is going to help you figure out your asymptotes, okay? There we go. So reminder, x's are going to be your vertical asymptotes, that's x equals h, and then horizontal asymptote is going to be y equals k. Going back to my question, the very first thing I want to do is, yes, figure out my asymptotes. So I'm just going to jot them down and make note of them. So I have a vertical asymptote here, vertical line going right through that looks like a value of 1. So I have a vertical asymptote at x equals 1. I have a horizontal asymptote, this time going left and right, and this looks to be at y equals 3. I know that from my quick trick here, if I have my origin of my two asymptotes, if I look out at that first coordinate either to the immediate right of it or to the immediate left of it, whatever that coordinate is, wherever it is, away from this one here, so this is 2 away, so that means I have a vertical stretch by a factor of 2. So this line here is a vertical stretch by 2. And now I have enough information to put into my equation, so here we go. So I have an equation of y equals, I have a vertical stretch of 2, so that's a vertical stretch is always on top. You have your x, and of course we have a horizontal, a vertical asymptote at 1, so it's going to be x minus 1 there. And then we have a horizontal asymptote, and this time it's at 3, so again I have small over big, which should be normally at 0 if I don't have anything, and then I'm going to go plus 3 to shift everything up 3. Again, I'm going to do the same thing over here on this next graph here. I'm going to write down my asymptotes first, so I have a vertical asymptote in this one is at x equals negative 2. I have a horizontal asymptote, and this time it's at y equals negative 4. And again, I'm going to look at that first coordinate to the immediate right and to the immediate left of that new origin, the origin of my asymptotes, wherever they cross. So to the immediate right of my new origin, more or less, is going to be 3 squares away, and even down here this is a difference of 3 away. So again, I have a vertical stretch by a factor of 3. So I'm going to quickly jot down my equation. So my equation is going to be y equals, I have 3 up top because that's my vertical stretch. Let me switch colors really quickly. I have 3 up top because that's my vertical stretch. I have my x, and it's going to be, usually it's going to be minus, and then here we had a negative 2, and then we're shifting it down 4, so it's going to be a minus 4 at the end there. Again, you should clean this up right here, double negatives. So this is going to be cleaned up to be 3x plus 2, because we went 2 to the left there. Oops. And then minus 4. Wait, which way are we going? We're going, yes, 2 to the left. And there we go. We have both equations done. In example number 5, it says state the vertical asymptote and horizontal asymptote of this function. So again, we're not really doing too much here. So again, let's look at our denominator first for our vertical asymptote. What can't x be? X cannot be positive 3, because then you'd make a 0 there. So x cannot be 3, so you have a vertical asymptote at x equals 3. You have a horizontal asymptote at y equals 1 over 1, usually, because this is 1 and 1 for coefficients and same degree, so it's 1 over 1. But we also have this vertical translation up 5, so that's going to play around with our horizontal asymptote. So this is now y equals 6. So you have now a horizontal asymptote at 6 instead of just at 1. In this next example here, we're just graphing out the following functions. We're going to do f of x on the left, and we're going to do g of x here on the right. So for this question here, I'm going straight to my graphing calculator to see what this is going to kind of look like. So I have my y equals already. I'm going to go 1 divided by x squared there just to see what our base function is going to look like in this case. And there we have it. We have our, what normally our rational function should have been one piece here in quadrant 1 and one here in 3. Because of the squared, we're both in 1 and 2. Everything's going to be above our x-axis there because we can't have anything below there. So that's what I'm going to sketch on for the first picture, or for the first graph, sorry. And imagine that I sketch that on. You're going to try your best to sketch it on. In the next one here, again, I'm going to try my best to sketch it on, and this time I will truly sketch this one on. But before I do that, I gotta figure out what my denominator here is. This here, we haven't run into this too often. This is x squared minus 6x plus 9. This here is factorable. If you can't remember how to factor this denominator, I would strongly suggest use quadratic formula or use your graphing calculator to help you factor. But in this case here, I know two things that multiply to 9 and add to negative 6 is going to be x minus 3 and another x minus 3. So here I have, this is basically telling me I have a vertical asymptote at x equals 3. So I'm going to draw a line straight down x equals 3. So 1, 2, 3. There we go. And then I'm going to go straight to my graphing calculator. I'm hoping to see something shifted over 3 to the right there once I graph this on. So, and by the way, if you're graphing this on your graphing calculator, please use brackets. You need brackets in your denominator. So you have x squared minus 6x. There we go. Sorry about that. Plus 9. And there we have it. We have basically the same graph, just shifted over 3 to the right. And on this new one, if you needed coordinates, I would just go second graph and pull off a few values. Pick whatever you can read as best as you can and kind of go from there. So I noticed that at 2, 1, there's a coordinate, and at 4, 1, there's a coordinate. So I'm going to put coordinate dots at 2, 1. So I got 1, 2, 2, 1 right here. And at 4, 1, because that's 3 there, 4, 1 is right here. And our graph's going to go right through it. So coming straight down, then that's my turning point, and so my graph is going to turn right through there. There you go. That's my first piece going forever in both directions. Coming down on the other side of that asymptote line, going through my turning point, and it's going to continue going on forever in the right direction. So here at the bottom it says state the following. So we're looking for domain and range, vertical asymptote, horizontal asymptote of the original versus the new. So what's my domain of my original? I can be everything except for 0. We're skipping 0 there. So I'm just going to write this in set notation. So I have a bracket x such that x cannot equal 0, but x is everything else though. So x is an element of a real after that. For my range, I am bigger than 0 there. I'm not below 0 ever. So I'm going to say for my range, y such that 0 is on our low end, y has to be just greater than 0. We can't be equal to 0 because we never truly touch our x-axis there. Then y is an element of a real. So where's my vertical asymptote? I have a vertical asymptote at x equals 0 and a horizontal asymptote here at y equals 0. On my new graph, my domain here, going left to right, well, going left to right, the only number here that we're skipping is positive 3. So I'm going to rewrite this as x such that x cannot equal positive 3, but x is an element of a real. And my range, same range, we're going to be greater than 0. So y such that y is greater than 0, and y is an element of a real. My vertical asymptote here is going to be 3 shifted over 3. So we have a vertical asymptote at x equals positive 3. And a horizontal asymptote that hasn't changed. So we have a horizontal asymptote at y equals 0. And there we go. Moving on, we have the following. So what happens if you needed to convert from this format, this a over x minus h plus k, to actual function notations where we have double function f of x over g of x. And we're going to convert backwards as well. So the very first thing that we want to do is convert this into two functions, two individual functions. There's no subtraction or addition sign in between. So I got to get rid of that somehow. The way I do that is building common denominators. And so my denominator on this first fraction here is x plus 3. Over here, I want that to become x plus 3. So I'm going to quickly rewrite this so that it's common denominator. So on the left, I have 2 over x plus 3. On the right, I have that minus sign, that subtraction sign still, 4, and to build my common denominator, it's going to be x plus 3 there. But you can't just randomly add on an x plus 3. I do need to balance that out with an x plus 3 in my numerator. And there we go. Basically, we took this 4 or negative 4 there, and we multiplied it by 1, because multiplying something by 1 doesn't really change it. But in this case here, we are trying to manipulate our equation. Here, we have common denominator. So whenever you have common denominator, you can start to combine your two fractions. And so in this case here, before I start combining, I do want to distribute out this 4 into this bracket here. So I have, and I'm just going to go right beside here, y equals 2 over x plus 3 still. Nothing's happening there. This minus sign. And then I have 4x plus 12. So I've distributed in this 4 to the x and 4 to the 3 there. And you still have that x plus 3 in your denominator. Now I could do a quick subtraction. So I have y equals, and I'm just going to write it all in one big. So that's 4x plus 12 there in brackets because I'm subtracting, and all of that's going to be now divided by x plus 3. Bringing in that negative sign so that we can combine things around. So I got 2 minus 4x minus 12, and all of that still divided by x plus 3. And just simply cleaning this up, we end up with y equals negative 4x, and you always want your variables first, x first there, minus 10. All of that's now going to be divided by x plus 3. And that's basically it, and we should be done. You might be asking yourselves, how do I know if you're right? How do you know if your final answer is truly correct? Well, what you could do is a quick check on your graphing calculator. So I'm going to go to my graphing calculator, type in y1, y2. In y1, I'm going to type my original function. In this case, it was 2 divided by x plus 3 minus 4. So I'm going to use my fraction function. So I've got 2 divided by x plus 3. And then after all that, a minus 4. In my y2, I'm going to graph the exact same thing that I just found here. So minus, so again, so I have my minus 4x minus 10 up top there, and then you have your x plus 3 on the bottom, plus 3. And all you're doing is looking for the same coordinates. You can either hit graph right away or second graph, and you have table values. And your table values, if you notice, they match up. Every coordinate here on your y1, y2 match up. If you hit graph, you're going to see overlapping, and so that means it also matches up. So you know you have these two equations properly done and converted properly. In example 8 here, we're going to go from this form here, f of x, g of x, back into this here where you have a k value by itself. Well, how do we do that? Well, the way that we're going to do this is we're going to build a common denominator. So the way that we want to build this common denominator, I see x minus 3 here. I want to make my numerator to become x minus 3 somehow. So I'm going to quickly rewrite my equation. So I have y equals my denominator. I'm not going to touch x minus 3 staying there. I have this x here and this positive 4. I'm going to write off to the very far right there. In this little gap right here, if I want x minus 3, I'm literally going to write down minus 3 here. Okay, I'm going to fill it in with the minus 3. But I can't just randomly add in a number, so I need to balance that out by adding the opposite sign. So if it's minus 3 here, it's going to be plus 3 right beside it, because minus 3 plus 3 is 0. I'm not really doing anything. I'm adding in 0 to this equation, which really doesn't affect our equation, but in fact it truly does. So once I'm here, I see this x minus 3, x minus 3. I can separate that off from this other half here. So I'm going to quickly rewrite my equation into two fractions. So I have x minus 3 over x minus 3. And then I have this plus 3 and 4. So I'm basically separating my equation right here. So the left side versus the right side. So then I have plus 3 plus 4 was in that numerator there, and then you have the x minus 3 right there. Cleaning this up, what do we get? I notice that x minus 3, that's just 1 there, folks. Then here it's going to be 1 plus, what do we got? We got 3 and 4 makes 7. 7 over x minus 3. And there we go. We basically have our answer, but I'm going to clean it up and write it one more time in proper notation. So we got a x minus h plus k there. Okay, and there we go. We have our equation written. For the very last example here, we got for the function 3x squared divided by x squared minus 2x minus 8, state the domain, range, all intercepts, and any asymptotes. So you're basically going to run this question in full, writing down all the characteristics, as many as you can, and sketching after you have all that done. So the very first thing I'm going to do is factor that denominator. That denominator definitely needs to be factored. So I'm going to quickly rewrite that equation. So we got f of x is going to be equal to 3x squared over, and that things that multiply to negative 8 and add to negative 2 should be negative 4 and 2. So I got x minus 4 and x plus 2. And the reason why I factored is now I can see from the bottom right away I have a vertical asymptote, and that's going to be at x equals 4 and at x equals negative 2. So again, right away in my graph here, I'm going to find 4 and negative 2 and draw vertical lines right through them. So here's negative 2 and here's positive 4. So my two vertical asymptotes drawn in right away. Let's talk about my horizontal asymptote. My horizontal asymptote, go back to your original equation, because in your original equation you haven't factored or anything funny yet. So in my original equation, I'm looking at the highest degrees everywhere. So I have x squared. I'm going to compare them. It's the same. So all I'm looking for is the coefficients. That's a 3. This is a 1. So I have a horizontal asymptote at y equals 3 over 1, which is just 3, by the way. So I'm going to draw a horizontal asymptote at 3. So there we go. There's that one there. After this, I can then try to figure out my domain and my ranges. So that's going to help my graph, by the way. So my domain is going to be, usually it's going to be all things except for 4 and negative 2. So my domain is going to be everything except for negative 2 and 4 for x. My range is going to be everything except for 3 for y. Okay. After this, I'm going to go straight to my graphing calculator to graph it and pull off coordinates to see where we need to graph on our grid here. So I'm going to scroll down so that I can start to graph this function. So I'm going to just load up my graphing calculator. Here we go. Clearing off my previous question there. So here, again, I'm going to use my fractional function. So I got 3x squared in my numerator, so 3x squared is right there. And in my denominator, the original was x squared minus 2x minus 8. And I'm missing an x. And there we go. That's the graph I'm going to try my best to graph. Again, second graph brings you up a table of values, and you're going to try to collect as many of these coordinates as possible. Again, I see an error at x equals negative 2. Why is that? That's our vertical asymptote. So I'm going to probably have a few coordinates here, as many as you can. Even though they're fractions, you're going to just try your best to graph as many of these as possible. And here we go. I just quickly sketched my graph here on the grid. And I think I'm still missing a few more pieces of this question. So domain, range, and all my intercepts. So off to the side here. So again, my domain is going to be x cannot equal my negative 2 and that positive 4 there, but x is an element of real. And yes, I know I'm missing my x such that, but I'm just running out of space. My range cannot be, y cannot equal positive 3, but y is an element of a real. Do we have any x-intercepts? Yes, and a y-intercept? Yes, so we have an x-intercept. And we're crossing our x-axis at 0, 0. And we have a y-intercept, and it's going to be the exact same spot. 0, 0. That's the end of our question. If you have any questions about today's lesson, please feel free to ask.